Good morning. Let us have one more lecture about DIP series lectures that we had. What today we will talk? I should finish the morphological image processing within today lecture, but what I have done, that I bring some MATLAB example, around 12 MATLAB example that you should do in your task, and also write the notes about them. Means that now from this stage or after the lecture, this lecture, we want your description and analysis about the result, which is more important. We may have some lecture like this at the end of our series about analysis of the results, which still I didn't plan more for that, but half of the job is done, means that it's not finished. I'm working on that to have that type of lectures. Mainly, it will come at the end of our lecture series. Um, Today we will review some codes and work on the basic morphological algorithm. At the last part of today, we have MATLAB's code. What we have done, we finished the student presentation. Two students didn't send me the um, presentation. Then, unfortunately, they cannot take the mark, and we also don't have time as we planned to continue for that part, and we should fully now work on mainly MATLAB parts and also the chapter which is remain. What we have object recognition chapter which we will start hopefully with the next lecture of this week, and color image processing part as the last two part that we should work on that. And mainly with these chapters we are working more with the MATLAB job and some project uh, based lecture, and also we have some review part about previous lecture, especially for the frequency domain. I prepare one uh, lectures that we will review and do the MATLAB, because we didn't do the MATLAB task for that part. Uh, anyway, let us see. That was the part that we talked in the last lecture about the basic morphological algorithm and application. About four part we talk, and four part is remain. Means that thinning, tinkering, and skeletons, and pruning is remain. Pruning, but we will talk little bit with two and three more algorithm here at the end for today lecture. Let us see again with the MATLAB's implementation as the example number one that I made, and let us see how it works. I think I should reshare my uh, desktop for you, and please just wait that. Okay. Uh, is it visible? Means my MATLAB is visible now?
Yes, sir. Yes, sir.
Yes,
Okay,
sir.
good. Thank you. Thank you. Thank you, Sadna. Okay. What we are going to do in this example is that first we are going to compare the erosion and dilation. If you see, I have done this job several times to give you the clear idea about the erosion and dilation. But with different sample work. From this task, you will work and see the real results on them also. Okay, let us run these codes and then we will see. Within these codes, what I will do first, I will read the image and then show the original image. Then I convert it to the binary. Some SE part of 5 by 5 I made that we had one example that shows the effect of this, why it should be 5 by 5 or 3 by 3. Okay, and then we store the number of rows in the P and number of columns in the Q variables, and then create a zero matrix based on them, and then compare the minimum value of the neighbors and minimum values of the pixels, and then we convert again to the binary, means that, and then we do the dilation, erosion. After that, we will do the dilation with the little bit same process of the 5 by 5 SE, means that the structuring elements are same. And then we will take again the minimum value of the neighbors and do the dilation job on the image. If we do this job, what will be the result? It's something like that, has the erosion and dilation. And I use the Lena picture as the fix, what we can say, fix image or main data. What I want now you write in your task is that what the difference between this erosion and dilation, what difference you can get from the image properties, means that this image and another one, what should be the difference from the size, from the colors, from the shape, from the what you can get, or what it can be highlighted here in this image. This is your job that I wanted you write about that. The next part that we are going to do is that based on color image, not RGB one, maybe it's a little bit different from what we have done. Uh, we review the concepts of the opening, closing, and eroded image here. Let me run it once more. Yes. Again, I use the Lena image, and first I will show it. Then I use the dilated image with the uh, function of sterile. I use line. That is something that you should, what we can say, find what the difference between how you will do it. Let me teach you. Very simple. Just copy this. Use this help. If you do this help, some short description will come from the MATLAB, which in that you can get some information. First is that, estrel is the morphological structuring elements. What it will do, they written here for you. You can read it, and this is what we use, this statement, line. Okay. You should write that why we have the line one. How you will do, very simple here. You see, with this line, they will create a line structuring element that is symmetric with respect to the neighborhood center. The next one element is dig or deg, which it specify the angle in degree of the line as they measured in the counterclockwise direction from the horizontal, and len is approximately the distance between the centers. Then easily you can understand what is this 7 by 7. Okay. Then we will do the dilation at the next level here with the IM dilate, I and SE, and then we print the dilation one. Eroded one also we'll use with the IM erode, and then we'll get the title on that. Then opening with IM open, closing with IM close. Let us run this program and see what will happen with the image of Lena. This example is important because till now we didn't first work fully on the color image. Second thing is that we can get the idea of what it will do with this result. See, suppose what's going on here. If we know this as the original image that I put the title in, then the dilated one, it's this, eroded one, close image, and open image. I want you also make the note on this. What will happen with the original image after dilated, eroded, closed, and opened image here? What it will happen uh, after reading the notes, and that you can write the clear concept about it. That was the example number 2 that we review. Okay, we talk about boundary extraction, which we can define it as an object by first eroding the object with the suitable small structuring elements, and then subtracting the result from the original image. Then for the binary image, suppose A and structuring elements B, the boundary AP can be defined as something like that: A minus A and then AB, like this, structuring like that. Read the first one. First eroding, that we showed with this eroding, and then subtracting from the result from the original image. Okay. I have one example again here that you can see the result of the working on this algorithm or these methods. Now, these are the uh, last lecture algorithm that we have done. See what will happen on the image. Suppose I have the circle image. I calculate the parameter there. Then we will allow the tick parameter extraction. Then print the single boundary pixels and tick boundaries here. Let us see. Yes. These are what we get from the original image and tick boundary, as is a single pixel boundary and tick boundary. See the boundary which become specified here, and maybe the image now it's become more clear than the input. Here we use two MATLAB function, which is BW prim and IM road, and boundary extraction, which is a single pixel tick, is implemented in this image MATLAB image processing toolbox through the function of BW prim, and arbitrary thickness can be obtained by specify an appropriate structuring element. Means that the SE, see, is from here, please. If you will see, we can specify how much thickness we need to have the better and maybe recognition of the image here. That was image number, example number 4 that we review it. Please, when you do these experiments and example, note down about the difference between the original one and maybe thick boundaries that you have. The next things that we review last lecture was extracting the connected components. You know, the set of all pixels which are connected to a given pixel, we call it connected components of that pixel. Then a group of these pixels which are connected to each other in this way is differentiated from the others by give it in some unique label. What we have in this method is that typically the process of extracting connected components leads to the new image in which the connected groups of pixels or objects are given sequential integer value like this. The background have the value of 0, the pixel in the first object have value of 1, and the pixel in the second object have the value of 2, and so on. Let us see one example about this extracting connected components that I write the codes for you that you can test that again. Uh, Simply what I use one basic shapes PNG. I think one person should remind me to send you the image that I use here. If you remind me when I take the rest for today, you can also have the same results as what I have. I think I forgot to write the CLC and close all and clear all, which now it will not affect the previous result. Let us do it step by step. First, I clear the rest, then I open the basic shapes, something like that, some reading image. Let us see. Then I use the BW label, which gave the label, image, and number of the object here. See what we have. In that image, I have two variables of L and num. Num is 4, which it will specify the number of the object that I have here. It said that you have 4 objects here. Let me see the main image. Main image 1, 2, 3, 4. Then it defined that I have 4 elements, or number of elements there. Then the next job that I have done, let me open my MATLAB codes there. You will get that I have the labeled one, and which is the matrix of L, and this is what we can get from the L. Then after that, we have done the subplots of image. We show the BW1, which is the read image. This is the image one. Then they have done some color job on that, and then display. Yes. This what we get from the output of this result, and it's connected components labeling. The image display on the left is the binary image, which containing the 5 connectors connecting of elements there. And the image on the right is the labeled matrix one, in which the first group of connected pixel is assigned of value 1, as you can see, and second group value of 2, and so on. The false color bar indicates the numerical value which it used for the connected components. Means that as the color change in the figure, you can see the different number of the connected value. See once more what we have here. We expected here around 3, the value between 2 to 2.5, it's from the circle. Below than around 1, we have here, and here it's around 5 for this shape. You will write the notes on this also example in our task part. Let us review one more algorithm, which is the region filling. I tell you the theoretical part behind these before, but review just in one slide page. As we know, the binary image usually arise in the image processing application, which are the result of thresholding or some other segmentation procedure on an input's gray or color image. This procedure rarely perfect or often due to uncontrollable variation in the illumination intensity that we saw. Means that finding the proper thresholding or finding the proper segmentation, somehow it's the tough job for us to find it. But after also doing this job, means that segmentation and rarely and mainly in threshold part, you will leave some holes. For example, background pixel within the binary object that emerge from the segmentation. One job that we have fillings the hole within this object. It's often desirable in order to subsequent morphological processing, which can be carried out effectively. Then we have this algorithm that we call it region filling. Let us test this region filling parts also. Okay, let me run it. Yes, I have CLC and close all, then no need to do this. Okay, then I read some text that you should have this image sample that I have. And then what I have done, we read the target shapes relevant with the prop job, then define the heat for that. Suppose this is my image part. I want to work on this. You should select. Okay. With this I am crop, you can select just like this. Then you have SE1 and SE2, which is the heat and mist structure elements that we talked before. After that, we perform the transformation on these two and then get the explicit coordination of our location. Now we go to show. First is our image with some X and Y part. Then we will display the target shapes, what I crop. And finally, we will superimpose the location of the image. Let us see. Yes. This is the part that I select, and you will see that it's work on the text and display the target shape. And the next is the superimpose of that part on the main image. This also what we have done. This is the application of the hits or mist transformation, which detect the target shapes in the string of text. One thing that you should see that the targets include the background, and hit or miss is strictly sensitive to both the scale and the orientation of the target shape. Uh, Suppose you can see the color plate section for the color version. And the function from the MATLAB that we use, it's BW hit miss, which it's from the image processing toolbox, and have the purpose made the function for carried out the hit or miss transformation. Then BW hit miss we use. This example illustrated use the identify the occurrence of the target layer E in the strings of the text. Let us see the output of this uh, example that we had, and it shows the SE results and as well as the PW part. Okay, you will write the notes again for this example. And let me again clear all this. and then go for the next lecture. That was reading filling parts that we have done, and the application for this hit or miss transform is, as I think we talked. Sorry for this part. That is for the target shapes. Okay, well, we had some generalization of hit or miss, which already we talked for these two equations that we have here, and was chosen relatively for some straightforward to understand based on these two formula. Something which is important is that to stress that it's actually a special case. The most general form of hit or miss transform can be given by this formula. In this formula, we have B, which is combine of B1 and B2, which signifies a pair of structuring elements. B2 is the general structuring element that is not necessarily the complements of the B1, but which is mutually exclusive. For example, something like the B1 and B2 should not be empty, and empty set. And by allowing the second structure, which we call it B2, to take on forms other than the complements of B1, we can effectively relax the constraint that the hits or miss operation only identify the exact targets and widen the scopes of the method for this method. Let us see this example. Actually, I think I do it little bit vice versa. This is the hit and miss example that you can write the notes on that. I should change this subject and even this example. We have some more example based on opening and reconstruction, which let us test this example also, example number 7. As I tell you that this series of work means that these lectures generally will take a lot of time for me to writing the code. That is why just in the lecture I use this copy paste that we can save the time. Otherwise, if we want to write all the codes from first, we have that lectures part also. I planned for that, but let us see how we will do. Okay, I have one shape that I call it open shape. What I will do, I will take the sterile of the disk type with the radius of 10, and then I will use the BW to I'm open. As you know, the function for the opening was I am open till now. Then first we show the original image, which we have here, and then we have the disk radius effect of opening on that. Let us see. Well, they have done it. See the shape, okay, star shapes, especially on the corner side. You will see that it's become rounded. Even see for the circle what it will happen, or for this rectangular. Okay, these are the effect of this open on that. And then we have the other square of 26, 25, and then opening with the 25 side. Let us see, and then opening square sides of the 25. This example is good because now you can find the different radius 10 and radius 25 in the sterile function of the MATLABs, and you can compare the results on that. You will see that the square size of 25 little bit it kill the image, especially the star, which have the loss, which have the more angle and also corner in its shapes. And somehow we can say that increasing these numbers will not uh, make the good uh, result on the image, but again it depends on the application and target that you have. But here suppose you can see that the star is little bit gone. It becomes little bit like the shirt instead of a star. Well, effect of morphological opening we have C on the original binary image result of opening with the radius of 10, and we will see that rounding on the points of the stars and the corners of the rectangle. Only the rectangle is properly resorted. The other shapes are significantly distorted and it kills the image. But anyway, depends on the application. We cannot say that this is bad or this is good now. We should know the target. We should know the aim of doing this job. Okay, the next example that I bring, this is the grayscale parts or grayscale. Let me see. Yes, grayscale erosion and dilation, which uh, we can have on the image. Uh, Let us run. I select the cameraman image on this example, and let us see and analyze it. First, I open it, then I define the first SE uh, matrix with that. Then we have the gray dilated image and erode image, and then subtract these two. I mean, we subtract the gray scale of dilated and eroded from each other, and then we show the result. Let us see the result. Yes, result is that I could take this cameraman with his camera from the background, and this is what we can get as the output. This may be used uh, in some object detection algorithm and maybe with that purpose, but still we can see in the object detection chapter that we have. You will see here the morphological method with the grayscale erosion and dilation and detecting the cameraman persons from the image. Then we have the grayscale opening and closing, which in that defined in exactly the same way for the binary image and their effect on the image. It's so complementary. Grayscale opening, which is erosion followed by dilation, will tends to support the small bright regions in the image whilst leaving the rest of the image relatively unchanged, where closing, I mean dilation from by erosion, tends to suppress the small dark regions, and we can see these on the next example that we had. And let me see this example again. Okay, let us. Uh, just 1 minute, please. Okay, what I have done here, I work on the rice image, and then we have the opening estimate background with the disk types and with the 15 as the radius there. Then we have the IM subtract and then improve the contrast of that, and then we will show. Let us see the results from these codes. Yes, you will see the original image, opening to estimate the background, subtracting the background, and improve contrast. You will see that here in this image and compare with the original ones. Now maybe you can even count the number of rice, which can be one application here. And you can estimate the number of the rice that we have there. Uh, this job maybe can easily use for the blood testing and counting the number of the some elements inside our uh, blood, and will be more useful. Um, I am erode and I am died. I am close and I am open may be used for both binary and gray scale image, which now we use for the gray scale one. Correction of non-uniform illumination through the morphological opening we have done in this example. And if we want to see left to the right, we have original estimate illumination function, which will be used by the morphological opening of the original. In the image number C, or the third one, we have the original with illumination subtracted. And number D is the contrast enhanced version of the image which we had. Here, what we can see the some good effect of opening and closing. If you compare it to the previous image that we have, that rectangular job and star job, now you will get that it has the good maybe on the good result and job on the source image that we had. Okay, that was for 9 examples that I have done for the first part of today's lecture. I found one article which is related to 2030. It's about, we can say, most of the point that you need to write the comment and the result image is here. Suppose about erosion, about dilation, they have done not very technical job, but it's good for students. Totally, I can say like that. Even they put some MATLAB code that you can just copy paste on that. I didn't use this article, but as I saw, that was not bad, especially from the conclusion part. Mainly, I can say this is not the article, but anyway, uh, it's good for students to read, and maybe you can get some brief description about the points that we already study in morphological part. I shared these two PDF for you. Mainly for this article, you can copy paste the code and run it on the image and also write the notes. It may help you to write the better notes on the. And now the second part of today, it's we'll try to finish the rest of the morphological algorithm and application. And actually, we should do that because this chapter should be ended, this lecture. And we have some more MATLAB code about this part. Okay. The number fifth, I think, algorithm that we have was thinning, which is another algorithm in morphological methods, which in that we can define this algorithm with the below equation like this, that if we have the set A by structuring elements of B, we can have the thinning as this icon, and then we know it as A minus A star B, and the A with the community of A and B like this, which is shows the act of tiling. A more useful expression for tiling symmetrically is based on sequence of structure elements that you can put on that, where we can see the version sequence of SE of BI till BI minus 1 in this formula. And here, the tiling of A by sequence structure of B can be shown like this. A, I don't know how we should call it, circle multiplication, or we know it as the tiling by B1 to B2 till B number n, we can know it as tiling. Let us see the effect of the image and sequence of the related structuring elements of tiling. We have the A sets, and these are the SE that we have. Suppose we have 8 set of B. First one is A1, which is A circle multiply. We can call it this icon of B1, means that act of this SE on these sets. Then it can be like this. This is whatever remain from that. Then A2, which will become of A1, will affect by the set of SE of B2, is that this one on this, it can come like this. Then B3, which effect of B3 on the A2. B4, effect of A3, you can see. B5, effect on A4. B6, effects on A5, and so on to A8. Then what we have result after converge, we can have a conversion of M connectivity, which is shown here at the end. See, this is the end one which we can get. This job we call it thinning. And then with other side, we have another algorithm that we call it thickening, which in thickening it's defined as this formula. And if you see there, we have the multiply, you have dot here. Okay. In that, we can have it as the thickening of A by sequence structure of B again, like this. And then in practice, the usual procedure is to thin the background of the sets and then complement the result. The whole job is like that. It's going to thin the background of the sets and then complement the result for that. Yes, let us continue. Can be one example that we have the set A here, and we have the complements of A there. Means that whatever we have there, we have the complements, convert between 0 to 1, 1 to 0, and then result of thinning of complements of A. It's something like that you can see here. And then thinked set obtained by complementing, means that again we will complement this part, we have this one, and the final result is something that you will see. We will remove the discontinuous point, means that these 2 points which are far from others, we will remove them, and just the points and pixels which are connect to each other will remain. Why we do that? Because we may know these 2 points as the noise of a system. Skeletons is another method, which in that for the set of A, has some properties of like this. First is that if Z is the point of SA and DZ is the largest disk centralized at the Z and contain A, one cannot find a larger disk containing the DZ and included in A. Then the disk DZ is called the maximum disk, and the disk DZ touch the boundary of A at two or more different places. See, we have the suppose set A here, and then we have the various points of maximum disk that we can have with radius, different radius. There. In the image C, I show the another maximum disk that on the different segments of the skeleton of A, and complete the skeleton will come like this. Uh, see the image, please. Yes, this is the complete part that you can make. Skeleton of A can be expressed in the term of erosion and opening with this formula, and which K can be the maximum of K belong to A minus KB, which is not empty, and SKA can be defined as the formula of the A uh, circle minus KB minus A minus KB dot B, where B can be the structuring elements like the equation, and K is the successive erosion of A. We can have the example like this. Suppose A uh, minus KB can be like this. Then A minus KB dot B can be performed as this one. Then skeleton of A can be just this remain part, and the skeleton union between K equal to 0 to K can be represented by these parts. Now you will see here that by the equation, uh, the original sets is at the top left, and its morphological skeleton is at the bottom of the fourth column. The reconstructor set is at the bottom of the sixth column. This is the reconstructed one. Uh, A as the set can be reconstructed from the subsets by using this formula, where Sk denotes the successive dilation of A. See once more, these are the results, which shows the skeleton based on the sets A that again can be reconstructed at the end. Pruning is another one, another method which is thinning and skeletonizing tends to leave some parallelistic components. Pruning methods are essential complements for thinning and skeletonizing procedure, something like cleaning. It's like that, which you can see the example here, which I have the original image, something like this. And here you will see the structuring elements which I have, and the result of 3 cycles we will see here. If I see the x1 as the A circle multiplication by sets B, I can have this one. And then for the x2, which is the unity of x1 and bk, we have that one. And then for the structuring elements of 3 by 3, the x3, it remain on these. And finally, with the union of x1 to x3, I can have this uh, form, which if you compare these two parts are removed from my shape, and maybe the shape like a small a in English alphabets, it's come to picture. Then morphological reconstruction is another algorithm which involves the two image and structuring elements. One image contains the starting points for the transformation. The image is called marker. Another image is a mask constraint the transformation, and the structuring elements is used to define connectively. Geodesic dilation is another method which we have supposed the set of A, which denotes the marker image, and G mask the image with this equation. The geodesic dilation of size 1 of the marker image with respect to the mask denoted by this method, which is defined with this equation, and geodesic dilation of size n of marker image F with respect to G denoted by this equation, and we can have the let us see an example. Suppose I have illustration of the geodetic dilation here. We have the marker and F and mask and G and B here, which it will do the marker dilation by B, and geodetic will just remain these parts on us. We can have more work on the geodetic dilation, which we will let F denote the marker image and G the mask image. The geodetic erosion of size 1 of the marker image with respect to mask denoted the EG1, which is defined with the below formula, and geodesic erosion of size n of the marker image F with respect to G denoted by this formula again. And now we can have another example, which have the marker of F, marker of G, and the B, and then marker denoted by B can be like that. And finally, geodesic erosion will come out with this image. Okay, we can have even morphological reconstruction by dilation, which is of a mask image of G from the marker image F, which we can denote as the RDGF, is defined as the geodesic dilation of F with respect to G, and is rated until stability is achieved, something like that, which we can use this as the below formula here. And the morphological reconstruction by dilation example you can have here. Suppose in example shape A, you have the DG1 dilated by B, DG2F, and DG2F dilated by B, and DG3F, and till the DG5 of the F. With the dilation, you can do the reconstruction. With erosion also, you can do the reconstruction, which in that you can use the mask of image G from the marker F, which we denoted of REGF, and it's defined as the geodesic erosion of F with respect to G, and it's rated until the stability is achieved, something like the formula that I show here, RGEF and EGF, with the K such as the formula which is mentioned here. Also, with the help of opening, you can do the reconstruction, and the opening by reconstruction size n of an image F is defined as reconstruction by dilation of F from the erosion of size n of F. We can have again this formula which mentioned below, and let us see some example. Suppose here you will see the text image which has the size of the 9080 till 2080 pixel. The approximated average of the tall characters is about 15 pixel. You should know that. In the second image, you will see the erosion of it with structuring element size of 51 by 1 pixels. The opening is shows at the C, I mean this image, and this opening will do the same structuring elements, and D is the result of the opening by reconstruction. Means that again after this, they could reconstruct the image. They could reconstruct their image based on the original image that they have. As we say, one job is to filling the hole. Suppose we have the sets of I, X, and Y, which is denote the binary image. And suppose that we for a marker image F that it can zero anywhere except at the image border. We can have this formula of F, X, and Y as an image. Then hole filling we can do like this in the different parts. We have the hole here from our image. This is the part that at the end it can be whole with this series of the mathematical equation. Suppose for this example, the text image of 9080 of 2080 pixels. First, you will see that they do the complement of the image, convert the white to black and black to white color, and then they use the marker image, and then result is the filling hole that they have. So you see that all the parts, something like D, B, A, O, P, and so on, some words are filled by this algorithm, means that by filling hole algorithm. One more thing that we should know in morphological, this is border clearing, which it can be used to screen the image so that only complete object remains for further processing. It can be used as the signal that partial objects are present in the field of view. The original image is used as the mask, and the following marker can be happened. Let us see the results. Suppose the same image, and that in that image, just 1 minute. Oh, sorry. In that image, you will see the marker image, an image with no object touching the border, and the original one will come out from the. Okay, now from the theoretical part of the this morphological job, I think we cover. Now let us again see some example number 10, 11, and 12 inside the MATLAB, and we can learn more from MATLAB job. Let me share my desktop with you. Then it will be good. Okay, can you see my MATLAB environment now?
Yes, sir.
Okay. What I suggest is that to just have the good review, that PDF is good, and somehow also refer from the book, because if we want to stop more for the morphological part, it may take more time, and we have some other chapter that we should cover. Okay. We will work on the image of rice. We will use the desktop structuring elements, and then we have the filter for that. Then we will display the original one and raw filtered image and construct adjust. Let us see what should be the output. Yes. This is what we will get after the image comes. This is the adjusted image and filter one. Then skeletonization that we didn't have till yet, and we just review it today. Here I read the image, and then with here view the original image and skeletonized one. Use BW scale for this job. Okay, then let us see. Yes. This is what we get from the image. This is the original one. This is the skeletonized one. Here you will see the border, which is more clear. Suppose one example can be if you have one electronic circuits and you want to know that all the points are connected to each other or no. This algorithm can help you more to detect the lines and circuits connectivity. Okay. Then the next example. Okay, this example is little bit big, but what I have done, I compare all the algorithms that we had till today. Let me first copy it there, and then we can analyze. If you read this code, in each part, I put the description which may help you to understanding better. I work on Lena image, and then first I change it to gray level and show it till here. Then this is my original image till now. Let us see. Yes, that is Lena, and this is the original image in gray. Okay. Then I create a structuring elements with the radius of 9, and then we'll go to perform the dilation using the immediate component and display the dilated image. Then if we remember Lena, the dilated one is something like this. Lena, and dilated one is this. See, it's still the image. And then we will go for the eroded image. What it will happen for the eroded image? Okay, this is eroded image that we learn. We find some internal boundary and internal boundary, which is the dilated image and not of the eroded image, something like this. And let us find the internal binary. You will see that this is all the algorithm that we read. This is the internal binary. Then the external boundary, how we will find? We will find for the next part. This is the external boundary. Then morphological gradient, dilated image and not of the eroded image will come to pictures with this morphological gradient algorithm. See, as the next step. Then we will perform the tining operation that today we will learn. We learn it. Yes, tining of the image. Then the tickering one that we had today. And finally, the skeletonization, which has the algorithm we had today. Okay. This image is the brief of whatever algorithm or application that we read today. And in one code, I try to uh, check all. You will may see the exact results of that. Suppose see the tining and thickening and also skeletalization that here, and even morphological gradient here. I think these can cover whatever you need for the morphological part. Purposefully, I write the codes which can help you to analyze and make the difference between them. Mm, and I don't think that you can get this code easily in your book because I combine lots of codes for that and get uh, these results. Yes, this is example number 12, an effect on the Lena image that you can see based on morphological operation. Okay, what I have here, I have one nice table, which it shows the MATLAB function, as well as definition of image structuring elements and description. This is the whole things that we want to say for this chapter. I found it from one source book, which it's not in your reference, but it's a good book. Not for your stage, little bit higher for your stage, but you can use some part. As we know, regularly some part of this book also. Some examples also I bring from this book for you. You will see that the function MATLABs that it use and also description, definition, which it will help us to have the better analyzation. I think this image, you should keep it in your mind. Let me give the uh, print screen and put it for you in the groups also. If you want, you can take the printout for that and have it in your notes. That was nice job. Let us see the summary for today lecture. Mainly now I will talk on whole morphological parts and should try to finish today lecture. Here you will see the 5 basic types of structuring elements. We use the binary morphology. The origin of each element, we consider it at the center point, which center which shows with the cross here, with this sign, and with don't care values. You will see here we have the operation and properties of the morphological in this table: translation, reflection, complement, difference, dilation, erosion, and opening. This is the mathematical equation, and this is the comments, means that what it will do on the image. It will help you to memory. We have closing, we have heat or mass, boundary, convex, tining, thickening, and skeleton. I will give you this. I think you may have it from in your book also, but I will share these tables also for you. These are the good summary. Uh, the job for the pruning, which makes the clear the job. Geodesic of dilation size 1 to n. Geodesic size 1 to n, which shows with the equation. Morphological reconstruction methods by opening, by dilation, by erosion, and reconstruction also. It shows hole filling and border cleaning. These tables are nice, I think, which can help you to review.